Okay, so today we're going to look at what's called an electrolytic cell, which is pretty much the complete opposite of a voltaic cell. So it's important to keep the two separate to understand the differences, and anything that you're not sure of after today's notes, we will discuss tomorrow. So as you can see, the picture looks very similar to our voltaic cell, with one big discrepancy. There's only one beaker in this electrolytic cell. So that's one of the main differences between the two. Voltaic, you need two half cells, whereas in an electrolytic cell, everything happens in the same container. There is still going to be a solution in the container. So if you want to indicate that like we did with the voltaic, right, that's going to be a solution, and we're going to say that that solution is silver nitrate. So I'm just going to write that out here. All right, and the important part of this is the silver ions. So in the solution we have silver ions. And notice that both electrodes are in the same solution. The good news is that the electrodes still have the same name. Over here, I'm going to call this the anode. And over here, I'm going to call this the cathode. In this case, the anode and the cathode are both two pieces of metal. However, when we talk about an electrolytic cell, sometimes you will see this electrode or one of the electrodes that isn't a piece of metal, but it's an object, like a key or a piece of silverware or a piece of jewelry. And the reason for that is because an electrolytic cell does what we call the process of electroplating. And so I'm just going to jot that down up here. The process of electroplating is plating a metal onto another metal object. And so for anybody that has any jewelry or has ever used silverware, that's exactly what made that object look the way it does. So your jewelry, for example, white gold. Gold is yellow. Okay, there's not something out there called white gold that you can just go find in the ground. White gold is yellow gold coated with another metal, and the process that allowed that to happen is called electroplating. If you've ever seen a key with, well, pretty much any key is probably going to be made out of fairly cheap metal and then just a thin layer of something shiny on the outside to make it look nice. So when we're talking about an electrolytic cell, we're typically talking about the process of plating a metal onto another metal. So we're going to say that in this case, the anode, I'm going to label it as silver metal. So this piece of metal right here is going to be silver. And we're going to say that we're not going to say it's any type of metal. We're just going to call it the object to be plated. It can be made of any metal. It doesn't matter. Because what we're going to do is we're going to plate it with silver. So the anode is always the substance that's going to plate onto the other substance, and the cathode is always the object to be plated. More good news, you don't have to switch what happens at the anode and the cathode. So oxidation still occurs at the anode. So over here on the left, what you're going to see happen is silver metal with a charge of 0 turns into silver ions, and it does that by losing an electron. So there's your half reactions for what occurs at the anode. Those electrons still travel through the wire, and they go from anode to cathode. But you'll notice a huge difference. We end up with a power source here in the middle. So before, in the voltaic cell, this was what we called the voltmeter, or anything that measured the fact that electricity was flowing through it. So when we made our batteries yesterday, some of you saw that a clock acted as the voltmeter, or you hooked it up to the voltmeter itself and saw that the voltage changed when you hooked it up. Huge difference in an electrolytic cell. There is no measurement of electricity because an electrolytic cell doesn't produce electricity. It requires electricity. And that's what this power source is showing us. So this could be a battery, labeled as a battery, and that's most typical. But the fact that it's here means that in an electrolytic cell, we require energy. So it's not producing energy like in a voltaic, it requires energy. And it requires that electrical energy that will eventually turn it into chemical energy. So it's the exact opposite of a voltaic cell. It's taking electrical energy and turning it into chemical. So we've got our electrons traveling from the anode up through the wire. That doesn't change. And it hits the power source. And if you pay careful attention to the charges here, this side connected to the anode is positive. That makes the entire anode positively charged. And then over here, this side, the cathode, is connected to the negative. That makes the entire cathode negatively charged. So we're actually forcing electrons from the anode, which is positively charged, over to the cathode, which is negatively charged. And this shouldn't make sense yet, because electrons are negatively charged. Why would negatively charged substances want to go towards another negatively charged substance? They don't. That's why it requires a power source. The battery actually pushes the electrons. It provides the energy for the electrons to move from anode to cathode. Once they're over in the cathode, okay, here's another place where it differs a little bit. These electrons, remember in a voltaic cell, are picked up by the ions in solution. Exact same thing happens here. It just so happens that the ions in solution are the exact same as the ions that you're producing here. So silver anode is oxidized, and it throws more silver ions into the solution. Okay, so when those silver ions meet up with the electrons, you end up with the reduction reaction. Silver ions gaining electrons and turning into silver atoms. Those silver atoms get plated on the outside of this cathode, and that's why we see things like jewelry with a shiny outer coating, because that metal actually forms that coating on the outside of that electrode. So the anode is still where oxidation occurs, the cathode is still where reduction occurs, but unlike a voltaic cell where we had two different metals here, one being oxidized and one being reduced, in an electrolytic cell, the same substance is being oxidized and then reduced, which is why it's so important to have that same ion in the solution. The electrons need to be added to those ions and plate themselves on this electrode over here. Okay, so that's the basic gist of what happens in electroplating. And this video is actually on my website, so if you're still not getting it after watching it once, by all means, please go back, listen to it again. If you turn to the back, just like with a voltaic cell, you'll see the important vocabulary. And we're going to write some things down here that will hopefully clear any questions that you have up. So anode. Anode is still where oxidation occurs, so that's the good news. Okay, electrons are lost there. The anode is still the place where the mass decreases, because you are still taking atoms and turning them into ions. Okay, we don't have to worry about the whole most or least active thing though, because it's the same metal being oxidized and reduced. So the anode, will be obvious because you should automatically be able to pick out the cathode in this one. The reason for that, let's talk about the cathode. The cathode is where reduction occurs. And the reason you should be able to pick out the cathode right away is because the cathode is always the object to be plated. So whether that be a key, a piece of silverware, just a regular piece of metal, it will always be the object that will be plated. And that's how you'll know that's the cathode, and therefore the other electrode has to be the anode. The mass of the cathode will still increase, and that's because you're taking ions from the solution and turning them into atoms. Those atoms actually get plated onto the cathode, and so the mass will increase. All right, the wire still has the same function as a voltaic cell. This is where electrons are transferred, and they still flow from anode to cathode, so that doesn't change. The fact that there is a battery or a power source is a huge difference from a voltaic cell, and this is because in an electrolytic cell, we're taking electrical energy and turning it into chemical energy. So it's the exact opposite. And the fact that it actually requires a power source means that this is a non-spontaneous process. So a voltaic cell was spontaneous, and electrolytic is non-spontaneous. It requires energy to happen. It doesn't just happen on its own. And then finally, the solution must have metal ions that match the anode. So in our example, we had a silver anode, therefore we had to have silver ions in the solution. That goes for anything. And then just going to go back up to the anode and cathode real quick just to point something out that we didn't mention with voltaic cells, and that is that in an electrolytic cell, the anode, because it has a battery attached to it and because the anode will always be attached to the positive end of the battery, we say that the anode is positively charged and the cathode is negatively charged. Okay, sometimes they want to know, sometimes they will label it as positive and negative, and you should be able to pick out anode and cathode from those representations in an electrolytic cell as well. All right, so now you have comparisons, voltaic, electrolytic. You are going to have a homework assignment tonight with some multiple choice and short answer that refer to both of them. There is a really nice table, I think it's the last question in your I can statements, that compare the two, and that's a really nice review. So in your I can statements tonight, they're not due until Friday, but if you could just try that last question in your I can statements comparing electrolytic and voltaic cells, that'll be kind of a nice review point tomorrow during class. All right, so for the rest of the time, you can work on your homework, you can work on your I can statements, and I will be here today after school during 10th period if you do want to stay.